Consciousness is one of the greatest mysteries of human existence. For centuries, scientists and philosophers have sought to understand how and why we are aware of ourselves and the world around us. Could consciousness be something more than just the firing of neurons in our brain? Roger Penrose, one of the most influential physicists of our time, argues that consciousness might arise from quantum processes at the very fabric of the universe itself. In this video, we'll explore Penrose's orchestrated objective reduction theory, or OR, a groundbreaking theory that combines quantum mechanics and neuroscience to explain the nature of consciousness. Penrose's exploration of consciousness is rooted in his belief that consciousness cannot be explained purely by classical physics or computation. In his earlier work, Penrose argued that the mind is fundamentally different from machines, which operate on algorithmic processes. In The Emperor's New Mind, Penrose questioned whether computation alone could ever explain the human experience of self-awareness, insight, and creativity. He proposed that consciousness may arise from processes that cannot be modeled by classical computers. However, Penrose didn't stop there. His later theory, orchestrated objective reduction, or OR, takes these ideas even further by suggesting that quantum mechanics, the branch of physics that governs the microscopic world of particles, may play a crucial role in consciousness. This theory was developed alongside anesthesiologist Stuart Hameroff, who brought his knowledge of neuroscience and the brain to the equation. To understand OR, we first need to understand how quantum mechanics might operate in the brain. Quantum mechanics describes the behavior of particles at the smallest scales: electrons, photons, and other subatomic particles. At this scale, particles don't behave in predictable ways. Instead, they exist in superposition, meaning they can be in multiple states at once until they are observed or measured. Once observed, the superposition collapses into a single state. Normally, quantum effects are only noticeable at microscopic scales, like atoms or subatomic particles. The idea that quantum processes could have a role in consciousness may seem strange because the brain operates at a much larger scale, where classical physics usually dominates. However, Penrose and Hameroff proposed that quantum effects could be sustained within the brain's microtubules, tiny, cylindrical structures within neurons that are vital to cell function. The microtubules, as it turns out, might be the perfect candidates to host quantum phenomena. These structures are both small enough and complex enough to potentially support quantum states that are more stable than those seen in other parts of the body. Penrose and Hameroff suggest that the quantum coherence in microtubules could be the key to understanding consciousness. Microtubules, which are made of protein subunits, could allow for the storage and manipulation of quantum information. This could explain how the brain might perform sophisticated computations that go beyond classical algorithms. According to OR, quantum computations happening inside microtubules are orchestrated in a way that directly affects the neural activity of the brain. These orchestrated quantum events could underlie our conscious experience, but the key question remains: how do these quantum states collapse into a definitive conscious experience? To answer that, we need to look at Penrose's concept of objective reduction, or OR. In traditional quantum mechanics, the collapse of a superposition into a single state happens when a system is observed or measured. Penrose, however, believes that this collapse is not random, but is instead driven by the nature of gravity itself. Penrose proposed that when a quantum superposition reaches a certain level of complexity, the gravitational effects between the different quantum states cause them to collapse into one definitive state. He called this process objective reduction, or OR. This collapse is not governed by observation or measurement, but by the fabric of space-time itself. In the context of the brain, Penrose argued that quantum superpositions in microtubules, as they interact with the brain's neural architecture, reach a point where gravity causes them to collapse. This collapse, he theorized, results in a moment of conscious experience, a key event in the OR theory. Now let's talk about the orchestrated part of OR. Penrose and Hameroff argue that the quantum states within the microtubules don't just collapse randomly, they are orchestrated in a coordinated, systematic manner. These orchestrated quantum events form the building blocks of conscious thought. This orchestration of quantum collapse events is thought to produce the kinds of cognitive functions that are associated with higher-level consciousness, awareness, reasoning, and understanding. The events are thought to be coordinated by the brain's larger structures, ensuring that they contribute meaningfully to our conscious experience. This is why Penrose named the theory orchestrated objective reduction. One of the most profound implications of OR is that gravity itself is a key factor in the collapse of quantum states into conscious experiences. While traditional quantum mechanics relies on observation or interaction to collapse the wave function, Penrose's theory suggests that gravity is the final arbiter. This view not only challenges the conventional understanding of quantum mechanics, but also brings gravity and consciousness into an entirely new relationship. This is a truly novel idea. Penrose and Hameroff propose that quantum mechanics and gravity are not separate phenomena, but are intricately intertwined when it comes to the emergence of consciousness. If the OR theory is correct, then it has profound implications for artificial intelligence. It suggests that AI, no matter how advanced, will never truly achieve consciousness unless it can replicate these orchestrated quantum processes. While AI systems may be able to simulate intelligent behavior, they would never possess the self-awareness or subjective experience that humans do, at least not through computation alone. Penrose's theory, in essence, tells us that consciousness isn't something that can be copied or simulated by a machine, as it is inherently tied to quantum processes that are fundamentally different from the operations of a computer. While the theory of OR has generated significant interest and some experimental support, it remains controversial. One of the biggest challenges is that the brain is a warm, noisy environment, and quantum states are generally unstable in such conditions. How can quantum coherence and superposition survive in the brain's complex dynamic environment? Nevertheless, researchers continue to investigate whether quantum processes in microtubules could play a role in consciousness. Advances in quantum biology and new experimental methods may eventually provide us with the evidence needed to confirm or refute the OR theory. Orchestrated objective reduction offers a bold new vision of consciousness, where quantum mechanics and gravity come together to produce our subjective experience. While the theory is still in its infancy, it challenges our conventional views of the mind and offers exciting possibilities for the future of both neuroscience and quantum physics. The search for understanding consciousness is far from over, but with theories like OR, we're taking crucial steps toward unraveling one of the greatest mysteries of all. Thank you for joining us in this exploration of Penrose's orchestrated objective reduction theory. If you enjoyed this video, make sure to like, share, and subscribe for more deep dives into the mysteries of science, consciousness, and the universe.